Hello, everyone. Welcome to the webinar, Office Workflows to Take Your GNSS Surveys to the Next Level. I'm Christine Grail with Leica Geosystems, and I'll be your moderator for today's session. Our presenter today is Burke Asay. Burke has 20 years of experience working with surveying technology. He began his career as a surveying technologist for Nantucket Surveyors in Massachusetts, where he developed his appreciation for fast, dependable, and accurate hardware and software. From there, he applied his field knowledge to developing System 1200 applications with a Leica North America software development team in Montreal. For the last 13 years, Burke has supported surveyors and engineers as an application and technical support specialist for spatial technologies and Leica Geosystems. Burke has a diploma in geomatics from the British Columbia Institute of Technology. Also on the line with us today are Bob Kilburn and Tim Kerr, who will be answering your questions behind the scenes during Burke's presentation and will also assist with the Q&A at the end of the session. If at any time you would like to ask a question, please enter it in the questions box, which you should see on your screen. We do have a lot to show you today, so it's possible we'll run a few minutes past the top of the hour when we get to the Q&A. If we are unable to answer all of your questions in our live session, someone will reach out to you after the webinar by email. Now, for those in the audience who already use Leica Geosystems technology, I just want to mention this is not intended to be a training session. We do have training courses available that will give you a deep dive on the specific features, functions, and applications of your hardware and software. If that's something you're interested in, I encourage you to reach out to your local representative for more details. What we will do today is give you an overview of the key capabilities so that you can be more informed as you use your current technology and as you look to make future investments. This webinar is the third in a series on GNSS technology. We will provide links to the first two events in the follow-up to today's session. If you've not had a chance yet to watch the first two webinars, I do recommend going back and reviewing those, as they were both engaging and informative sessions. And with that, I'm going to turn it over to Burke to get started.
Thanks, Christine, and hello, everyone. Thanks for joining us today. In the previous webinar, my colleague Bob Kilburn outlined the technology in Leica Geosystems' current line of GNSS sensors and field software. The Captivate field software is very capable and can be all that is needed when doing traditional single-point measurement. The data can be exported as an ASCII file or DXF directly from a CS controller and imported into CAD. However, there can be limitations in what is capable with the field software, especially in regards to new technology. This includes data like point clouds from the MS-50 or 60, and data measured from a tilt-corrected GNSS sensor, or images taken from an imaging total station or GS-18I. To be able to provide enhanced data editing and processing, an Office software package is needed, and this is where Leica Infinity fits in. Some in this webinar may not be aware of what Leica Infinity is. Infinity is designed to manage, process, analyze, and provide quality control to all types of field survey. Measurement data, including total stations, digital levels, GNSS data, as well as more specialized data sets like point clouds and imagery from GS-18Is and unmanned aerial vehicles. This allows users to combine data, verify data, and visualize data in a single software package. Just one note, all of the examples today include image processing, and due to the nature of image processing and the time that it requires, a real-time walkthrough is not possible. So we'll look at 3 pre-recorded examples that include time lapses that cover everything from simple processing tasks to more complex workflows like importing image data from a UAV. So here's our first example. We'll look at how we can use Infinity and integrated data sets to verify traditional survey measurements. And now we'll look at the video. This data set may be familiar to those who have been to previous webinars. This is the Leica Geosystems Montreal office and parking lot. The project includes multi-station data from 2015 and GS-18I data measured just a few weeks ago. And looking at the data in Infinity, we can see something right off, and there's an issue that we have to look at. The points icon in the library shows an exclamation point. This means that there are points out of averaging limit, which typically means a standard point numbering error. By isolating the average points, we can find which points have the numbering issue In this case, points 3000 to 3004. Removing the point rule filter, and then isolating points in the 3000 range allows us to verify that there are total station and GNSS measurements from two different Captivate jobs with the same point ID. By opening the computed average dialog, it confirms that the points are in vastly different locations. And this is most likely just a simple point numbering error and not a bad measurement data. So to fix this, we can just rename or renumber these points. So if we select the GNSS data from the GS18I job, we can use the rename, renumber feature to easily rename these point IDs. The rename feature allows the use of expressions to develop new point IDs. In this case, we're going to use the current ID and an integer to develop a unique entry. And this will make it 93,000. And then hit apply, we'll update those point IDs. Most edits and actions in Infinity have an option that will prompt for a report to be created. This report can be named and saved to track changes or edits in the software. Once saved, the report is stored in the archive, so it can easily be found in the future. And now this point numbering issue has been resolved. And you'll notice this because the exclamation point is now gone from the points symbol in the library. Next, we can use the view window to verify the measured data. There's a lot of data in Captivate job, GNSS observations, total station measurements, points, lines, point clouds, images. There can be a lot of data. And all of that data, if desired, can be displayed, but inversely can also be hidden on the 3D view. To hide data, we can use the survey data selection of the layer manager. And here we can turn off the TPS observations. We'll also turn off one other thing. It's the image frustrums. Frustrums might be an unknown term to you, but I will explain this a little bit later in this example. So what stands out now is the line work created in the field and also the points that were measured. And again, this can be checked just visually, looking for crossing lines or lines not meeting. But as GNSS data is inherently georeferenced, it is possible to use the included background imagery to verify the line work. So here we'll turn on the hexagon imaging program and the background imaging will stream. Zooming in, we'll see that there is a slight shift to the image due to the reference used, but it is still helpful in being able to determine if line work is missing or incorrect. There are a few ways to edit line work, such as adding points to the end of a line or to the start of a line. In this case, we're going to add a point to the start. It's as easy as selecting the point and confirming the change. From now, we can just scroll through the 2D view and look for additional issues. Here's another point or a line that needs to be edited. And we can fix this line work easily in Infinity. But there is one thing to be aware of. Infinity is not a replacement for a drafting application. It does have simple and effective tools that allow the editing line work, such as adding points, removing points, joining and splitting lines, but it's not meant to be a CAD replacement. But once these points and lines are edited, they can be exported using ASCII point coding or directly to a DXF or DWG for use in developing a deliverable in your CAD application. Okay, we verified some line work using the 2D view mode and the background imagery. We'll now inspect in the 3D mode. And to do this, I'll just turn off the streaming image. Viewing in 3D allows another very common error to be isolated, and this is the rod height error. Here we'll see the top, back, and bottom of a curve, and it is pretty obvious that there is an issue. As Captivate and Infinity stores all of the raw GNSS measurements, it is possible to verify this in the inspector. The GNSS measurements are found under the GNSS tab. Here we'll see all of the vectors and all of the other related info. Scrolling through the list brings us to the points of interest, GS0019, 20, and 21. What we can see is the antenna height is displayed as 2.8, where it appears that this is the type one should be 1.8. This can be easily changed by selecting all of the points and editing the height. Measurement data can easily be batch edited for most major field errors, such as antenna heights for GNSS and rod height and prism constant for total station measurements. The reason that this is important for GS18I data is that tilt measurements, when taken, affect both the horizontal and vertical position. And a standard ASCII fix to correct an elevation data is not possible with GS18T data. It needs to be fixed inside of the Infinity software. Right? We can see here now that by making that change, and you'll see here that this is a tilt measurement. You'll see there's a column there that says tilt. So we would have to make this change to get the correct horizontal and vertical position for this data. And this is where we can make that change. Okay? We see that the points and line work has been updated. And everything looks as it should be. So we're going to continue here with the bottom of the curve, and we will verify the line work against the point cloud that was measured with the multi-station. Scrolling along the line, it appears correct. But if we zoom in a little closer, what we'll notice is the line starts to creep up the face of the curve. The reason for this is the bottom of a curve becomes the top of a curve because of a ramp, and the bottom of the ramp was not measured. We can clearly see this from the point cloud data. And what we can do is we can fix this by using the point cloud. We can create a point cloud by selecting an area in the point cloud where we want that point to be created. We can then select create point from cloud. We can enter or name the point. We can code the point. And then we can save the point. Once it's saved, it's a standard point that will inside your standard point list and database. Okay? We can then add this point to the line. And the line will be updated. This line has now been fixed for your export out into CAD. Right? And we can see here that it does follow the bottom of the curve. All right, now we'll change the view and pan around, and we're going to see a line of points, which are image points from a GS18I image group. They're these points here. And we're going to use these images to verify an interesting feature I noticed when I was initially looking through the data set. I was inspecting the line work to make sure everything looked correct, and I noticed this area here, where there is a large change in the height of the curve from a corner running around the curve. I assumed it was a bad shot or a bad rod height, but we had the GS18I data, so I was going to use it to verify. Okay. So what I'm going to do is I'm going to turn back on the image frustrums, and we'll see these in the 3D viewer. When the image frustrums are turned on, what they are is they are the image from the GS18I and the perspective of the image. Right? The image is degraded, but it is possible to verify features, and we can see that the curve is readily visible. If we want a better look at the image, we can select an image point, verify the image group that this point is in, and we can open up this image group in the image viewer. All of the points in this GS18I image group will be displayed. And we're looking for image number 54. This is the image of interest. And it's possible to zoom in, and the image verifies here the curb was damaged, probably hit by snowplow, and the line work does do a very good job of representing what was in the field. And this could all be verified in just moments by having this image data available. How this line work was plotted wouldn't make or break this project, but it does outline how the image data can be used solely on its own without any additional image processing for verification and site awareness. The 10 minutes it took out in the field to take all of these images with the GS18I could alleviate a return visit. Right? More can be done with the image viewer. If a point needs to be measured or created from an image, this is the place to do it. This is the same process Bob showed in the Captivate software in the last webinar. When looking at a point in an image group, Infinity tries to find the same pixel in the adjacent images and uses photogrammetric techniques to develop a unique point. To do this, we'll identify a feature, in this case, the corner of the curve, and we'll look for the middle image in the group that that feature is available in. All right. So in this case, this is image number 53. We can right click and select new point and select the feature in the image. A calculated point is displayed and the images used for the calculation are shown in orange. Additional images can be added manually and the point can be recalculated. Once we have the point we'd like, we can name the point, code the point, and then create the point. Accuracy of this point depends on photogeometry and distance, right? Typically, this position quality will be similar to a GNSS measured point. And in this case, we'll just do a quick measurement between the GNSS measured point out in the field and the calculated point, and it's approximately 3 centimeters, which gives us in the accuracy standard of GNSS. Right? There's something else that we can do with this image data, because we do have an image group. It is possible to create point clouds from these image groups. This uses the same image processing options as is UAV image processing that's available in Infinity. The main difference is that the image group orientation is calculated in the field for GS18I data. So developing a point cloud from GS18I data is very simple and requires only a single step. Inside the processing settings options, we have to just select a couple of things, and this would be the processing resolution, filtering threshold, and minimum number of matches. And again, I'm not going to get into the settings that we need here, but we just have to set them appropriately. We could talk about that in training, okay? Once the settings are set, it's just as easy as going into the image tab. Oh, sorry, and just starting the dense point cloud. The tasks for these projects or the tasks that are created are under the imaging tab, under tasks, as seen here. However, the processing tasks, they're not in this project. They take place outside of the project in the background in something called the task manager. This runs independently of Infinity and can also be managed independently. So it is possible to keep working in Infinity on other tasks or even close Infinity and the processing continues. The processing can even be handed off to another computer or a server to optimize efficiency. As this processing takes time, we'll just transition forward until the processing is completed. All right, so we return back to the project and we'll see that the processing has been completed, but the data hasn't been stored. So we can just select these processed point clouds, select store, and now these will be available inside the 3D view. All right. So this is a very simple example of only a few small image groups, but even in this limited data set, there's still plenty of things that can be verified using this point cloud. and measured with this point cloud. We have curbs, we have parking stripes, parking surface, trees, buildings, catch basins, and even just for visualization, it gives us a sense of the site. All right. Moving on to the second example, we'll use a combined data set, including UAV data, to get an extended scope of a larger project. So we'll just move on to the video here now. So here, this is an example of the main office in Heerbrugg. The data set is larger and gives a good example of all of the combined data that can be used in Infinity. This includes terrestrial data, GNSS data, GS18I imaging data, and UAV data, which was all collected at different times over the last 5 years. Currently, only the GS18I data and the georeferenced images are active in the 3D view. Right. Zooming in, we will first focus on a roof overhang. This will be our initial area of interest. We'll turn off the georeference image, and we'll focus just on the GS18I data. So selecting an image point allows the determination of the image group, and this image group can be opened in the image viewer. Here we'll see the roof overhang is visible. And the reason for this example is to highlight one of the unique features of the GS18I. It can measure points in obstructed areas, like under this roof overhang. You'll notice the HDS target. This would be very difficult to measure accurately with just a GNSS receiver, but not with the GS18I. As with the previous example of creating a point from images, find the middle image that the feature is visible, select new point, and select the feature in the image, and the point is calculated. Adding additional manual selections is possible. The feature just has to be selected again, and this can help with quality. Now the point can be named and stored. All right, so returning to the 3D view, I'm just going to quickly turn off the image frustrums. And this will just make the view less cluttered. And turn back on the terrestrial data. You'll notice that the terrestrial data included multi-station scan data, and the HDS target was measured. The point measured with the GS18I matches almost perfectly with the multi-station data. I'll just change the visualization of the point cloud here so it's a little bit easier to see. All right. So that would have been very tough to measure with a standard GNSS sensor, but a 20-second image group allowed us to be able to measure that point out in the field. All right. Now, panning the view, we'll get a better idea of the data that has been measured with the terrestrial data set. Turning off the TS observations here gives us a clearer view of the data. And what we'll notice is that there are points, lines, point clouds, and a traverse. The other thing that we do notice here is there's an area of the side of the building that was not able to be measured by the multi-station, but there is a GS18I image group. Right. So let's look at the images that we have available in the project. You'll notice that there are 9 image groups, 8 are terrestrial or GS18I image groups, and 1 is a UAV image group. We can't process the terrestrial and the UAV at the same time, so we'll just select the terrestrial. We'll verify our settings as we did in the previous example. And set them appropriately. And it's just as simple as a single button click of selecting dense point cloud. We didn't talk about processing times in the last example, but processing is related to kind of 3 main variables: the number of images in an image group, the resolution setting value, and the processing power of the computer being used. Processing times on full resolution GS18 image data can range anywhere from a couple of minutes to a half an hour, but it really comes down to the machine you are using and how capable it is. But as you know, you can run this processing in the background and you can do other tasks while it's happening. All right. With the processing completed, we will store these point clouds. Once these point clouds are stored, they'll be immediately available in the 3D view. But I'm going to isolate the 3D, the UAV data, or sorry, the GS18I data here. And we'll just look at the multi-station data first. Okay. You turn on the GS18I data, and you can see how much that the data adds to the scene. The side of the building wasn't measured at all. With a couple of two image groups, and approximately probably 5 minutes of field time, all this additional data was added, right? And you could measure windows, doors, heights of buildings here, all from just a couple of minutes out in the field, right? Well, 5 minutes probably. Christy, I think the video's stuck there. Oh, there we go. So as we scroll through, what you'll see is the rest of the side of the building. What we're going to do is we're going to inspect the side of this building here because it gives us a good idea because there's multi-station data, there's GS18I point cloud data, there's also a reflectorless measurement all in one spot. So we can kind of see the accuracy of the GS18I data. So we'll zoom in. And what we'll do is we'll just toggle on and off the data to kind of show you how accurate this data is. All right. So we'll first turn off the terrestrial data and then turn it back on. You'll notice that the reflectorless point is in the exact same position as the corner of the GS18I data. And then turn off the GS18I data and turn it back on. This data is very, very close. I'm not going to show a measurement here, but it is within probably millimeters of the multi-station scan. Look at a couple other options here. There was a manhole that was measured with the multi-station and also was picked up by the GS18I data, and that's visible. And they're in the exact same position. We'll take a couple more examples of how the GS18I data ties into the terrestrial data. And you'll see this line work here. This was measured with the total station. And you'll see that the edge of curb matches in perfectly with the GS18I data. And we're going to look at one additional example here on the other side of the pond. So we'll just pan over. And it's going to be a group of concrete benches that were measured with a multi-station. And the point cloud is from the GS89. You'll see the points there and how well they match in with the point cloud data. All right, from an overview, there are still some gaps in the point cloud, but we have the UAV data. All right. And what we can do is process this now. So we can go to the imaging tab, and we'll be able to see the UAV data or the aerial photography. And what I'm going to quickly do here is just rename the image group to image group UAV just to isolate it. It's something I do just to be able to isolate the data. So we have two additional steps that we have to do with UAV data. We have to create an orientation, and we also have to add control points to optimize the orientation. This is to ensure the UAV data is in the same reference coordinates as the terrestrial and GNSS data. The settings for these tasks are in the same image processing settings dialog we've seen in the last couple of examples. So we're going to set these settings appropriately for the data that we have. And we can right click and choose the orientation task. Again, this task gets pushed to the task manager. And kind of a standard time for this would be, anywhere from a couple of minutes to 10 minutes for an orientation. And that'll run in the background. We come back now and the orientation is completed and can now be stored. Right? With the orientation stored, it is now possible to do the second task, and that's adding control points to optimize the orientation. By selecting Add Control Points, the Add Control Points dialog becomes visible. And here points from the terrestrial or GNSS data can be used to rectify the UAV photos. And this is a big advantage for Infinity. The software can use typical control points, but it can also use total station measured points, GNSS points, or points created from scans or from images directly in the single software. Any of these points can be used to control the UAV data as long as they are identifiable in the images, which gives us a lot of flexibility for adding data sets to control if needed. Once all the control is selected, the match points dialog is displayed. Here, the viewer is used to match the controlling points to a pixel in the image. It is recommended that each control point be visible in 4 unique images. The process for 9 control points here took about 8 minutes. So I sped up the video so we didn't have to sit and wait. You will notice, however, the image in the lower right-hand corner. When points are controlled in the software, the symbol changes to a blue triangle. When done, there's an option to update orientation on finish. This will automatically start the orientation optimization task, and it'll be sent to the task manager. And here it's running. Right. We'll come back with the optimization completed, and it's possible to store the optimization. And now we're at the same point that we would be with the GS89 data. We have an orientation for the image group. And now we've seen this a few times. We just select dense point cloud, and here we can create the dense point cloud. Again, this will run. And we can come back to the project, and you'll notice that the dense point cloud is created by opening up the optimize orientation tab. And you'll see that there's a dense point cloud. We can store this, and this will become automatically available in the 3D view. For visualization purposes, I will isolate the GS18I point cloud data. And we'll go through what each of the different combined data technologies brings to the overall scene or project. All right. So the GS18I could bring points and also the point cloud data, which we see here. Adding the terrestrial data, we'll see the line work and points that are available from the multi-station data. And lastly, we'll add in the UAV data so we can see our complete site. All right. We'll do one thing here. The optimization of the orientation actually creates a sparse point cloud, so I'll just turn that off. And now you'll see we have a complete point cloud with a complete site with very little gaps. And now this point cloud can be used for anything from calculation or editing. Something to be aware of is there are additional tasks that we can do in the imaging. And those additional tasks are being able to create orthophotos and also digital surface models. So this is also available in the UAV processing package or the image processing package. But because of time constraints, we're not going to do or look at that today. All right. So as mentioned, this is a point cloud, and this is data, and we can take this data and we can export it out for use in any other software, either additional Leica software, CAD softwares, or other point cloud processing software. And we can export Leica proprietary files or industry standards as well. Here I'll export an LAS file. And when we export data, just like with reports, it will be saved into the archive. So we can find it and use it in the future easily if needed. All right. So now on to the third and final example. This is a data set of a small stockpile. We'll use the data from the stockpile to perform some calculations. And now we'll just see the video. All right. So this data set includes only GNSS measured points and image groups measured with the GS18I. The points are shown here in the inspector. And the points in image groups are shown in the 3D view. This is a single image group with just over 100 images that took approximately 1 minute to capture, an additional minute to store using the CS35 in the field. So just about 2 minutes of field time. Turning off the image group, we can isolate the GNSS measured points. And we can select these measured points and create a surface. By selecting surfaces, create new surface. The surface can then be named. And updated by selecting apply. In the 3D view, we can see a very traditional stockpile surface from individually measured points. Right. Now let's inspect the images in the image group from the GS18I data. And this can be done by selecting the image group tab and opening the image viewer. The first thing that we're going to notice about the stockpile is it's not very uniform, with large pieces of material, rocks and rubble. And the stockpile, and as the stockpile is so variable, the single points used to develop the surface may not accurately represent what is actually in the field. On another note, traditional measurement of stockpile like this could be a safety hazard with a high risk of slipping and falling. And using the imagery keeps us distant and would be much safer. As we have the images available, let's make a surface from the image data and we'll compare these surfaces. As in the previous examples we've seen, the images are processed through the imaging tab, and it's required to verify and update the image processing settings with appropriate data before you start processing. The settings will be set, and we can process the dense point cloud. And again, this is push to the task manager, and we'll process in the background. All right. So we'll come back now when the processing is finished. Again, to see this in the 3D viewer, we just have to store the point cloud. And it become available in the library and the 3D view. So we're just going to clean up the view by turning off the images, the points, and the surface from points from the library. Now it's possible to just visually inspect the point cloud in the 3D view. And you'll notice it did a really good job of representing the actual stockpile in the field. However, from the inspection, you will notice there is some noise to this point cloud. And this is typical when you are doing point clouds from imagery. There can be some noise. There are a couple of different ways we can clean up noise in Infinity. We can use the lasso tool to select noise or parts of a point cloud, and then just delete them individually. This will delete the point cloud and update the view. Secondly, and a far faster tool, is the ability to select the entire point cloud and then select the clean points function. This function includes an algorithm that will search and remove any noisy data. When the point cloud is cleaned, it is now time to develop the surface. A surface in Infinity is just a container. We can put in any type of data into this container, points, lines, point clouds. That data can, this data can be measured from different sources, total station, GS18I, or even UAV. And the software will combine all this data and develop a tin. So here I'll create an empty surface to which I will add the point cloud data. And the surface type is going to be interpolated, as this is the best algorithm for noisy and inconsistent data, which this data is from, because it's from an image from a point cloud, or a point cloud from an image. The surface can now be renamed and updated, and the empty surface will be shown in the library. Now to add this surface or develop this surface, all we have to do is add data to it. So we just need to select the point cloud or the area of the point cloud that we'd like to have in the surface. And to this, it would be about making sure it's in the correct area in the view, and then using the lasso tool. We just have to trace around the stockpile. We can add the data selected to the surface, and the surface will be created. Right? We can now inspect this surface in the 3D view. And we can see it does a pretty good job of representation. And it's easier to see this if we turn on the point cloud, and we'll see the surface here. Okay, if we do need to remove any of the surface, if anything was inadvertently added, or if there's some issues with the surface we might need to remove, we do have a tool for that. We'd use the lasso tool to select the area. And then there's trim triangles, and this will remove that data. And again, we'll just reorient to the image, or sorry, the 3D view, and we'll look at a different section here, and we'll remove another section of the triangles. So editing the surface is quite simple. So here now the surface has been updated, and we're going to call this done. All right. I'm going to turn on the original surface from points. And you'll notice here that we can compare the two, just visually. And you'll notice that the initial surface from points is just an estimation of the actual surface. All right, we'll turn off this surface from points for better visualization. But even with the surface off, we can still use the data for calculations. Right? There are 4 options for creating volumes in Infinity: stockpile, 2-point, 2-height, or surface to surface. Because this is a stockpile, we're going to use the stockpile option to create volumes or calculate volumes for these surfaces. So first I'll select calculate stockpile and select surface points. By selecting calculate, it will develop the volume. And you'll see here the surface, this surface or this stockpile has a volume of 35.4 cubic meters. And a report can be automatically created, named, and saved to the archive. All right. Now the volume for the surface from point clouds can be calculated. And this is shown as 30.6 cubic meters, which, if I did my math correctly, is approximately about a 14% difference. And this is a significant difference from the traditionally measured surface. As we can see from this example, GSAT image data can be collected quickly and safely, then be processed easily, and in most cases gives more accurate and richer data than with traditional GPS single point measurement. And if this is being done to monitor material usage, materials are money, and so this could really help with profitability. The last little tool we're going to look at here is the comparison map functionality. This is where any 2 objects can be compared against each other. In this case, we have surfaces. So we'll compare the first surface, surface points, to surface point cloud, and develop a color ramp. And this will develop a heat map that we can see and visualize in the 3D view. Hitting OK and create will create the heat map. Again, it won't be visual or it won't be visible directly. What we have to do is actually turn off the surface. The surface will cover this. So we have to go over to the library and turn off the surface. And we'll see the heat map. Again, this isn't a typical use for the comparison map or the heat mapping. It would typically be used to monitor a stockpile over time or for things like floor flatness and verticality, but it is a good visualization of the differences in the 2 surfaces. And finally, we'll just make a report from this comparison map. And this is done by selecting comparison map in the library. Right-clicking and selecting report. And again, this report, just like the other reports and the data that was exported, can be saved and it'll be held for future use in the archive. All right. So in the short period of time we've had today, we've looked at a lot of different applications for using Infinity, anything from simple to more advanced. And especially with the newer technology, it brings value to your data. And I hope it has generated some questions. And with that, I'll pass it back to Christine.
Thank you, Burke. That was excellent. Yeah, we do have some questions that we want to go ahead and address. I'm going to ask Tim and Bob to go ahead and share their webcams at this point too. I just want to remind everyone who's in the audience that if you do have questions, you can type those into the questions box. We are running close to the top of the hour right now, but we will address as many of those as we can. And we're willing to stay on the line just a little bit longer if needed as well. So please go ahead and enter those questions if you have them. One question I have for you, Burke, just as a point of clarification, is now you showed in all three examples, this was GS18I data, and that's our new visual positioning sensor, and it was processed in Infinity, which is the Office software. Is the Infinity Office software necessary with the GS18I?
It's not necessary. You can still, to develop point cloud data, it is probably recommended, but the GS18I data or imagery data could be processed potentially somewhere else in another imaging processing package. And you could also use the GS18I data just out in the field. We can't develop point clouds out there, but we can use it to develop single points in the images, like Bob had shown in the last webinar. So if you haven't seen that, you should reach out or watch that. But the GS18I does not require Infinity, but it does allow us to develop point clouds easily and allows us to better utilize that data.
Excellent. And of course, in one of the previous webinars, we did show how you can do measurements in the field using the Captivate software right there in the field. So we will make sure to provide links to those webinars after this webinar, at the conclusion of this webinar. Another question that I had for you is with regard to what computer requirements might be needed. You mentioned that the processing time would vary depending on your system. I would imagine you're working with a lot of images now. If you have the 18i with Infinity, you're working with a lot of images, a lot of data points, a lot more than what you would have with a typical GNSS system. So do you have a recommendation for system requirements?
I don't have an exact system require recommendation. We could probably find it on the spec sheet, but I will tell you from my own experience, I have what's called a salesman's laptop, and it takes longer on my machine than it does than Bob or Tim's machines that they have. They have more of a workstation machines, and I have just a standard laptop. And the standard laptop probably isn't recommended. It can still do it, it just takes longer. Right? But the GS18I data can be processed very quickly with a workstation or a higher power computer. Yeah.
So you don't need any special considerations then. You just need to make sure, like with anything we're dealing with now, you need to make sure your system can handle data.
Exactly.
Okay, excellent. Tim, I know that you and Bob have been monitoring the questions very closely on your side. Do you have anything that we should address next?
Sure do, Christy. Scott brought up a very good question in terms of the accuracy of the data. Can it be improved by setting and measuring the control points? And I think, Burke, it would be good to address this from a UAV point of view and the GS18I point of view.
So the GS18I image group is exactly the same as a UAV image group. If you control the data with control points, yes, it will update the orientation and make the data tie better in with your local data. So if you do have a reference change or something happens, you can take that image group, reprocess the orientation in Infinity, and it will become more accurate. Yes.
Okay. But with the GSI on a day-to-day basis, is that really necessary or?
Not necessary. Just as we showed in the examples, just hitting process or using the orientation that comes in from the field is all you really need, yeah, from a day-to-day basis. Yeah.
Okay, excellent. Another question that came in from Steve is what's the limit on the image group size for the GS18I? Is it time? Can you walk up one side of the road, down the other, et cetera, et cetera?
Again, on the field side, the limitation is 1 minute, and it takes one image, 2 images every second. So you can get 120 images in a single image group. But image groups can be merged together. I didn't go through that, but it is possible to merge image groups together. So you can stack image groups in the software. But the one thing that does happen is you lose the orientation from the field because we're adding in more data, and you'd have to run that orientation task on top of if you do merge that data together. Right.
Okay, excellent, excellent. The small surveys done with the photos like on your stockpile, are there speed issues if you're using the CS20 controller, the handheld controller versus the tablet? What would be the differences in that regard?
Yeah, so the CS35 has more computing power, so it is quicker. I don't have the exact numbers, but I would say it's probably takes about twice as long for the storing of the data using the CS20. So the CS35 is probably recommended, but the CS20 does work and it is effective. It just takes a little bit longer out in the field.
Burke, I'll add a little something to that. So it really depends upon the length of the image group that you're processing as well. So if you are processing a full 60-second image group, it goes up exponentially. So it may take up to twice as long on the CS20, where if you have a 15 or a 20-second, a small image group, they could be closer to equal or just seconds apart. So the longer the max, as you maximize the RAM on the device, it can determine how long it takes to process that.
Thanks, Bob.
Okay. And then a question came in from Shannon. Could we use cell phone images to create point clouds inside Infinity, similar to what Matterport and some of those applications are able to do?
I'm not sure, but I assume so. If we can use standard UAV imagery, I believe so, but I've never tried it. If you want me to try it, Shannon, I'll do it and I'll give you a call.
Yeah, I'm thinking the answer to that at this point in time is probably not. But I could be wrong. So we'll put Burke into a little bit of R&D for the weekend.
Yep. There you go. That does raise a question of, what types of data can Infinity reasonably handle? I mean, Burke, you showed us in that second example, you had total station data, UAV data, scan data, all brought in with the GNSS data. Is there really any limitation on the type of data, or maybe the timeliness of the data? Because in that example also, I think that went back 5 years of data collection.
Yeah, you can, again, the time doesn't matter unless there's changes on a site, again, Infinity is made to kind of combine data sources, and that could be GNSS, level data, imagery, GPS, any of those major surveying tools, and also can be brought into Infinity and used. Yeah.
And I would think that's a benefit, especially when you're working on longer term projects, or projects that, a lot of projects are kind of living things, right? And you want to go back into that data. You want to be able to access the quality control and the reporting at any time. And so having that available in Infinity is a benefit.
Yeah, again, reporting and everything is archived, and you can manage these projects quite easily in Infinity, that's for sure. Yeah.
Okay, excellent. Bob, are you seeing anything else from your side?
Nope, not big ones. There's a couple of small ones that we're answering on the side, but at this time, I think we're pretty caught up.
Okay, excellent. Well, thank you again to all of you who are on the line today. I do hope that this has provided you with some valuable information. Burke, thank you for taking the time to give us this presentation. I do encourage you, if you'd like to learn more about the GS18I or Infinity software or any other surveying solutions, please do contact your local representative or dealer, or visit pure-surveying.com. Just a reminder, as you exit the webinar today, please fill out the survey that should pop up on your screen. We appreciate your time and hope that you found this webinar to be a valuable experience. Thank you so much, everyone.